All right. Good morning, guys. Hope weekends were nice and things went smoothly overall for you as you were taking the test. Everyone who's currently here, test scores are in and graded and submitted back to you. Things went very well overall, so congratulations. Really, the only main points from the test that I just want to reiterate are, namely with WebAssign, make sure you're checking what unit WebAssign is asking for the answer to be in, because, and I know this from my own experience, I'll work the question through, get the answer in the unit that normally pops out of the equation, like, base farads or base meters or something, and then WebAssign goes and asks for the answer in terms of like picofarads or millimeters or something. So be sure to double check what unit WebAssign is asking for the answer in terms of, because that'll help eliminate any other issues on the grading end of things. And double check which formulas you're using for any given question. Make sure that it is related to the principle you're related to the principle that you are currently being asked to investigate for that specific question. And as always, make sure to send me any questions as they come up while you're working on something. But test 2 went very well overall. Very proud of you guys. And we're in the final stretch now. The exam will be this week, and all that's really left to do is study for that. So my plan for today is to just go over all the various study materials that exist for that, and then tomorrow will be a study, work on homework and quizzes day, and then Wednesday the actual exam will launch. Let me know any questions, etc., that you have right this second before we get started, and then we'll look over that material, make sure everyone understands how the exam will work. All right. So, the exam will look a lot like tests 1 and 2. It will pretty much literally resemble tests 1 and 2 smashed together, because it'll be the content of both on a single assignment. It'll be designed to take twice as long, so it's designed to take 2 hours. You will have more than 2 hours. It'll be over WebAssign, and like with the tests, a timer will begin counting down when you open it. It'll be a 6-hour timer. So the questions themselves will be designed to take 2 hours. You'll have far longer than that to take breaks, ask questions, make sure you understand everything before the timer runs out. Content of the exam, if you go to our Brightspace page, there is a final exam tab. Within that tab is a topic list and some more practice questions. The topic list lists all of the stuff from all the stuff from the past, well, really from the past entire 2 months of this course that will be present on the exam in some way, shape, or form. There obviously won't be a single question about all of these things, because if it's about twice as long as a test, there'll be about 16 to 20 questions on it. And each question will probably represent more than one of these concepts. Like there might be one question about one big resistor circuit, and you use what you know about resistors and current and Ohm's law to work through that one resistor circuit question, and that kind of represents that might represent the entirety of the chapter 17 or something like that. So the purpose of this list then is kind of like with the last study list. Make sure you look over it, make sure everything on it sounds familiar to you, you understand what it's referencing, you know which formulas are related to that principle as you're studying, as you're going through things. And we'll look over that whole list of things now, because it's been about a month since we actually talked about heat and thermo. So let's just do some quick review. Chapter 10 was about thermal energy itself. Main things we covered here that you should be aware of. We talked about the three methods of heat transfer: conduction, convection, and radiation. Conduction is probably the most important one for the sake of all the other math that would follow, because in Chapter 12 we looked at the math behind thermal conductivity. Radiation is useful to keep in mind, though, because that does technically tie into the light stuff that we talked about last week that will be present on the exam. So methods of heat transfer, talked about the various temperature scales. Make sure you recognize Celsius, Fahrenheit, Kelvin, when to use each of them, how to convert between them. And the other two math parts of Chapter 10 were talking about thermal expansion and the kinetic theory of gases. So as things heat up, they will expand. This applies to solids, liquids, and gases. And gases, because they do not have constant volume, have their own extra set of requirements when they expand. Chapter 11, energy in various thermal processes. We looked at specific heat capacity. That's the idea that different materials take different amounts of thermal energy to change their temperatures. We used that formula and that concept in various problems relating to calorimetry, which is just the technical term for using specific heat capacity to look at how much energy did something lose as it changed temperature, and therefore how much energy did something else gain as it absorbed the thermal energy out of it. As a reminder, Newton's laws, energy cannot be created or destroyed, so if something heats up, something else had to lose that same amount of energy to make that happen. And we did several questions where we say, dropped hot metal into a bucket of water, the energy lost by the metal would be the energy gained by the water, and we would use that to determine what the final temperature would be, or maybe what the specific heat of the metal was. So that genre of questions is what the term calorimetry is referring to. Chapter 11 also included phase change, the idea that when something reaches the temperature of a phase change, it then takes extra energy while its temperature remains constant in order to actually cause the phase change. For example, using, say if something was melting, you would look up its specific heat of fusion, latent heat of fusion, multiply that by the mass, and that tells you how much heat is needed to melt that particular mass of material. This is energy in addition to the energy needed to get it to that temperature in the first place, and its temperature remains constant while the phase change is being undertaken. It's only once the phase change is done that any extra energy loss or gain then changes the temperature of the newly created altered phase. It is only once the phase change is completed that its temperature will continue to change as more thermal energy is added or removed. And Chapter 11 also had rate of thermal conductivity. That was thermal power, calculating the speed at which heat transfers through something based on its dimensions, what it's made of, and the temperature gap on either side of it. Chapter 12 was the laws of thermodynamics. The way that I ask test questions about the laws of thermodynamics, there will be one question, kind of like with test 1, where you'll have to identify which law is which. So the laws will be listed along with a few distraction statements that aren't laws of thermodynamics, and you'll have to apply the correct number to each of the statements that are laws of thermodynamics. So out of a list of 6 things, pick out which 4 are laws of thermo and 2 of them won't be laws of thermo, and then number the ones that are accordingly. So you don't have to memorize them, but you have to be able to recognize them. From those laws, we talked about additional math related to these laws. The first law involved work done by a system and heat engines. So add thermal energy into a system, it expands, it does work as its internal volume and pressure changes. Be able to calculate the work done by such a machine or the work done on it. We also talked about thermal efficiency of these machines as they undergo their heat cycles. It takes a certain amount of energy put into it for it to accomplish a certain amount of work. And 99.9999% of the time, you always have to feed it more energy than the work it accomplishes. So all machines are, to some level, physically inefficient, and the efficiency tells you how much energy actually becomes output. The metabolic rate part and energy over time, that's mostly just related to power. Metabolic rate is simply the power of a living organism, so I wouldn't worry too much about that exact term. I would actually just probably alter this statement to just power and using energy over time, because machines use power, human body use power. It's just the rate at which energy gets used, the rate at which work is performed. Don't worry about the metabolic rate part. That's just power applied specifically to a living organism. That is all of the heat and thermo stuff. That covered the first month of the course. That was all on test 1. Then chapter 15 through 20, where we were kind of skipping around, is the electricity section. Chapter 15 was about charged particles and the forces between them. Coulomb's law refers to the force between two particles with charge. It works very similar to the universal law of gravitation. Coulomb's law, if you get a positive number out from it, will be a repulsive force. If you get a negative answer from Coulomb's law, that will be an attracting force between two charges with opposite signs. And these charged particles exert force on each other because of the electric fields that they are giving off. Those fields, when they interact with another field, will create the force. So for chapter 15, be familiar with charged particles, Coulomb's law, and the fields that these particles give off. Chapter 16 was about capacitors, largely speaking. Capacitors are devices that have electric fields in them, uniform fields that remain the same strength as you move horizontally through the capacitor. These capacitors store charge and electrical potential energy, as the particles within have their potential change into kinetic as they move from one side to the other. Be able to calculate the capacitance of a capacitor and understand how capacitors work together in circuits. So take a bunch of capacitors in series or in parallel, be able to calculate what their total capacitance would be. Chapter 17 was about resistor circuits, and I actually lumped chapter 18 stuff into that. Again, we were kind of skipping around, so choosing the important parts of electricity to cover for the syllabus. Main things to remember for the chapter 17-18 combo section were the idea of electric current being what flows through a circuit, voltage being sort of the pressure that pushes the current through a circuit, and resistance being, well, how hard it is to push the current through a specific component of that specific circuit. Those three things work together in the statement V equals IR, which is called Ohm's law, to represent the difficulty to which voltage can push current through a circuit of X resistance. Electrical resistance has its own couple unique formulas to it, namely determining the resistance of any given object based on what it's made of, its dimensions, and also its temperature. So make sure you're brushed up on that set of formulas. And components in electrical circuits use a certain amount of energy in a certain amount of time. They have their own power draw. Each component in a circuit will have a different power draw based on its own unique voltage drop, current through it, and resistance. From electrical power, we talked a little bit about how kilowatt hours and electric bills are calculated. So make sure you can look at a sample question related to that and be able to work it. As for resistor circuits themselves, we did look at how resistors work together in a circuit, like how capacitors work together in a circuit. Interestingly, the way that resistors add up is opposite to how capacitors add up. So capacitors in parallel add up like resistors in series, and capacitors in series add up like resistors in parallel. So in addition to capacitor circuits, be able to look at resistor circuits, determine not just what their total resistance is, but what the total voltage through them is, the total current through them is, and be able to determine what the the current through each piece should be based on its configuration, and what the voltage drop across each piece should be based on the circuit configuration. Namely, in parallel, all elements have the same voltage drop, but a different chunk of current as the current splits. Meanwhile, in series, everything has the same current running through it because there's only one path for the current, but everything will have a different voltage drop as different chunks of the voltage are needed to push the same current through each resistor. So, a lot to the circuits part of the chapter. Chapter 19, and I labeled it as chapter 20 as well, was about how magnetic fields interact with electricity and electrically charged particles. Namely, if a charge is moving through a magnetic field, the magnetic field is capable of exerting a force on that charge. There's a formula for how that works, and there's a list of right-hand rules for determining what the direction of velocity, field, and resulting force must be for that interaction to actually work. So remember the right-hand rules and how those three things apply and are always perpendicular to one another. We then talked about a couple of the different ways that magnetic fields can affect objects with either moving charges or objects with current running through them. It works on charges moving by themselves through space with magnetic field, in which case, because the force is always perpendicular to the direction of motion, a single charge moving by itself through a magnetic field tends to start moving in a circle, and that's what the magnetic force as centripetal force part is referring to. That formula where we used determined the radius at which a charged particle would continuously spin through a magnetic field. That's the principle used in mass spectrometers that we talked about. Magnetic field would also act on a wire with current running through it. That's this piece right here. Magnetic field will act on a wire with current running through it. The field will exert a force on the wire itself. The wire will also generate its own magnetic field, and that's what interacts with the other magnetic field in the first place. And if you coil a wire into a loop and put it in a magnetic field, it can be used as a motor because magnetic field acting on a loop with current running through it will generate torque on the loop and make it start spinning. And there is a dedicated formula for just that. So, main takeaway from chapter 19 is magnetic fields act on moving charges, whether or not they're moving on their own or in a wire, and there's various formulas for the different circumstances that takes place in. That was all that was just on test number 2, just the electricity and magnetism stuff, skipping around from chapter 15 to 20. The additional topics that we talked about for about 2 days last week were light and optics. We were just jumping around between what I think are the important aspects of light to be familiar with. Namely, that light is a wave, it has wave behaviors, it is specifically an electromagnetic wave that doesn't require a medium, that's why it can travel through space. It is a form of radiation, and so objects with energy can give off light and other forms of EM waves as a form of getting rid of energy, as a form of radiation. Light is physically made of an electric field and a magnetic field, which kind of ties it into the magnetic chapter from the weeks prior. Light travels at light speed. You can use that to determine wave speed in conjunction with wave frequency and wave length. Can tell you what kind of wave you're looking at, tells you what frequency of sound you're hearing or what frequency of light you are seeing. And we talked very briefly about 3 wave interactions: reflection, refraction, and absorption. These things determine basically how you see things. Light reflects off of things, it is absorbed by the cells in the back of your eye after refracting through the lens of your eyeball. Just briefly going over these concepts and how you've encountered them in the past. There will be concept questions about light on the exam. It will make up a very small amount of the exam because most of the class has been heat and thermo and electricity. So about 8 questions on heat and thermo, about 8 questions on electricity and magnetism, maybe 1 or 2 questions about light-based concept questions. So not the largest part, but just the concepts that I think are most useful for someone to know coming out of this class. And that is all of the concepts that will be present. So this is a good list to glance over as you are studying. Additionally, I'm going to go back up to the top of the course page real fast. There is the updated formula sheet at the top of the page. This has all the formulas you could possibly need for this class and more. That said, any formula sheet that was given out as a part of this class is available for you to use. For example, I gave a dedicated formula sheet for each test. The concept sheet for test 2, for example, has all the electricity formulas in it and labeled. You're allowed to use literally any formula sheet that the class has given out for this particular test. If you've made one yourself, that is also okay. And within the exam study tab, there is also, as with the previous 2 tests, a list of practice questions that you can go over. As with all of my practice guides, there are more questions here than there are on the actual exam. I always make my practice guides longer and more difficult than the thing they are practicing for, because I'd rather you make mistakes here than on the actual assignment. But you can use these for practice. There's several concept questions here on this particular first page of this document. I might have to update it a little bit because we didn't actually talk about transformers. So if you do this practice test, you can ignore that particular question. Go ahead and tell you that one. But there's also math questions that go over each of the individual concepts that we talked about. So good practice. If you do work on it, let me know if you have any questions or issues as you are going over it. In addition to these study materials, you still have access to all of the tests and homeworks and other things that you've done so far. If there's been any assignments that you haven't completed yet, like you haven't maybe done one of the quizzes or one of the homeworks is still missing a question or 2 on it, going back over those is an excellent way to study. Make sure you've taken every homework and quiz. You don't want a missing grade in one of those categories. Finish up all the homeworks, make sure you understand everything on all the homeworks, and make sure you've attempted each of the quizzes for each of the chapters as well. Excellent practice. Very low stakes. You can retake the quizzes if you stumble on them. You can let me know what questions you have, because like if you make a quiz attempt, something doesn't quite make sense, ask me about it, and I can tell you what you need to know before you attempt to retake it. And then you also have these practice questions here that you can use. I've been rambling for a little while. I believe that's that's all the information that you'll really need. Exam is just everything we've been doing up till now, and you guys have done very well up till now, so I don't have any doubts that you'll do well in the exam itself. So that's the course. You guys are just about done. There's only really one more major obstacle to get through, and then that'll be it. As I said, the exam will launch this Wednesday the 3rd. It'll run through Friday night. That's just so that I have time to grade it over the weekend before grades are due on Monday the 8th. So you will absolutely know how you did on Monday the 8th. When you take the exam, as with the tests, I want you to email me scans of your work when you're done, because the work is what I actually care about, and I will adjust what WebAssign says your score is based on that. And I will also email you back from whichever email you sent me your work on. I will email you back your score and just general tips about how you did, things that you should remember moving into the future. So by Monday the 8th, you will have your grade not only for the exam, but also for the entire course. If you need to know or want to know your grade calculation going into the exam, like say, want to make an A in the class, how well do you need to do on the exam to make that happen, you can ask me that at any time. I can go through how I calculate the grades with you. And as a brief reminder, exam makes up about, let's check the syllabus actually before I misspeak. On the syllabus, the final exam is reported as 30% of your overall grade. The exam has 2 tests worth of questions on it. It's 220 points graded out of 200. So like the tests, there is also still bonus points built in. It's literally just 2 tests crammed into one for the most part, just with the extra light questions stapled on. Since it's 30% of your grade, as long as you actually attempt it, and it's very easy to get at least 50% of it as long as you're trying, you could, I'm not sure what point I was trying to make there. Whenever exams come up, my students are always worried about, oh, how well do I need to do? Do I have to get within a certain bracket to get my A in the class? It is entirely possible to bomb the exam and still pass this class with a B or a C, because it's only 30% of the grade. So as long as you get, a third of the points on it, it's still possible to get a B in this class. So I'm not worried about any of you guys. If you are worried, I'm trying to tell you this as an encouragement, as a comfort. I fully believe that you guys are going to be just fine with this. And again, if you want me to calculate your grades with you, I can do that with you. I believe that's everything that you guys need to know. That's the class. That's the past 2 months of summer. So all that said, let me know what you guys need as you're studying. If you have questions right now, chime in and ask. I'll be in this room as usual for the next hour or so if you hop back in with any other questions. Tomorrow will just be an open free study day. Work on homeworks, quizzes, etc. Hop in as you have issues. And then Wednesday, the test will open. The exam will open. I'll still be in this room during normal standard kind of times while the exam days are happening, in case you take it during that time or you jump in with more study questions. Additionally, if while you're taking it you want to talk through a question, kind of more like if this was a traditional class where you'd be taking it in the same room as me, we can jump into this room together as you're taking the exam. If you tell me what time you're taking it, I can try to be here during it, so that we can discuss things verbally in this room instead of via text over email. I find that the verbal explanations work a little bit faster than waiting on an email reply. But whatever you're comfortable with, whatever you need, I am at your disposal, and I'm rambling because it's the end of the class and I always feel like I'm missing something. Let me know what questions you guys have, and if you don't have any right now, it really has been a nice time teaching you guys this summer, even though summer classes and online classes are always kind of weird. But it's been fun with you guys, and I appreciate you, and I know you guys are going to do great. So let me know what you guys need as you need it.